Jai Hind. Today we are going to discuss regression techniques. In this particular lecture, we'll start with introduction, and in particular we'll talk about linear regression and logistic regression, followed with by the definitions of regression. And one more thing we are going to discuss here, how the linear regression or regression formula can be used for classification before deriving or before thinking or talking about the formula of logistic regression. So, to start with, we are having different statistical techniques. So, we are having two analyses to study for the purpose of association. So, what are those two? One is regression analysis and another is correlation analysis. So, the first base that should be clear to us, the first point that should be clear to us before we are starting with regression is what is correlation and how it is different from linear regression. Correlation. Correlation is concerned with measuring the strength and direction of the association between variables. It talks about measuring the strength and direction of the association. While what is linear regression? Linear regression is concerned with predicting the value of one variable based on the value of the other variable. We call it regression of y on x. It means we are given value of x, based on that we find the value of y. This is our independent variable and this is the dependent variable. So, we are having two analyzing techniques for association, for analysis of association. So, in this particular we are talking about the second one, that is regression. So, mainly here we have used linear regression to represent the regression technique, and later we will talk about how this linear regression can be applied for classification purpose, and we will define the concept of logistic regression. So, to start with regression, where do we use it? Linear regression models are well suited to estimating continuous quantities. So, it will talk about real continuous quantities when we are having we are not having discrete values, these are continuous quantities, then we use linear regression, and it can have any wide range of values. For example, if I talk about price of some car, it could be 1.5 lakhs, it could be 10.5 lakhs, it could be 22.5 lakhs, it could be 10 lakhs, 20 lakhs. So, any that is the continuous quantity. And if we talk about identification of some digit, so a digit can be 0, 1, 2, 3, 4 up to 9. So, that is not continuous quantity. So, where do we use linear regression? Where we are having estimation of continuous quantities. Identification of digit is discrete. So, we are talking about here continuous quantities prediction, estimation. So, that is done with help of linear regression. Logistic regression is for classification problems. The second thing, what we talked about, the digits. Digits are discrete values, 0, 1, either the digit will be 1 or 2 or 9 or 8, 7. So, that is a classification problem. For that we do classification, logistic regression. So, what actually is done in logistic regression, the statisticians, they have adopted regression model to classification purpose. The Pearson coefficient, Pearson correlation measures the degree to which a set of data points from one straight line relationship. What is the degree of relationship of set of points? That is measured with help of Pearson correlation. Regression is a statistical procedure that determines the equation for the straight line that best fits a specific set of data. Regression is that procedure with help of which we will find out the straight line that will best fit the set of data, the data set we are given. Any straight line can be represented by the equation of the form. We all know that y is equal to mx plus b. M is the slope and b is the intercept. Here we are using the constants a and b. B we are using for the slope. The value of b is the slope constant and it determines the direction and degree to which the line is tilted. For example, line can be standing line. It is parallel to y-axis. It can be horizontal line. It can be some tilted to some extent, more tilted, and so on. So what we are having, we see this direction with help of slope. This is found with help of slope. And what is a? The value of a is called the y-intercept and determines the point where the line crosses the y-axis. So if I am having this as the x-axis and the y-axis, this is my x-axis, this is my y-axis. So if I talk about this line, I can see that what is the slope of this line, that depends on this tilt, how much it is tilted, that we measure with an angle theta. And what is the slope of this line, that is m is equal to tangent theta. M is equal to tangent theta, that is slope of this line. And what is this a value? What is the y-intercept? It determines the point where the line crosses the y-axis. Where the line is crossing the y-axis, that is this particular point. So this is our intercept. So this m is taken as b here, b is the slope, and a is taken as the intercept. So b is m here and a is taken as the y intercept. So this is the straight line equation which is used for linear regression. How well a set of data points fits a straight line can also be measured. It is measured by calculating the distance between the data points and the line. So let us understand with an example that if I am having these 4 points, 1, 2, 3, 4. So I need to do the linear regression and I will find the best fit line. So if I find a line like this, so how good it is, how well a set of data points fits a straight line. So if I take this straight line, what can I find out? I can find out the total error, how good fit it is. So the total error between the data points and the line is obtained by squaring each distance and then summing the squared values. What does it mean? We will find out the distance between the point and the line. We will square it and then add up. So this is our sum squared error. So what is our purpose here? What we want to do? What type of line fit we want? How do we want to fit a line? We want to fit a line that will have this sum squared error as minimum. Okay, so what is the regression equation? It is this. What is the aim behind? To minimize that error. So the regression equation is designed to produce the minimum sum of squared errors. So what is given? We are given line equation, that type of line we will form from the given data set, from the given set of points. And what type of regression equation we'll try to find out? We'll try to find out that equation which will have minimum sum squared error. When we are talking about correlation correlation is shown on this particular slide, that this is linear correlation, linear relationship it is having. So if we see this particular diagram in this figure, when x is increasing, y is increasing. So this is positive correlation. When we are we are going through this diagram, we can see that as x increases, y decreases. So accordingly we will get the equation. But linear equation doesn't fit well in these type of relationships. These are curvilinear relationships. So we are studying the linear relationships here with help of regression. In regression, we predict the value of dependent variable from the independent variable. The independent variable is input and the dependent variable is output of the linear regression. In correlation, the two variables are treated as equal. As we have seen on the last slide, we were having a linear correlation. In one diagram, x was increasing, y was also increasing. So both were taken as equal. But in regression, one variable is considered independent and the other variable is considered dependent. So which I called just before that it is independent, that is input, that is actually the predictor, and the output is the outcome variable, that is y. So x is predictor and y is predicted, that is the outcome. So this is our regression equation. When we are given the regression equation, we will have for one input variable two indeterminate, two variables we have, two constant we have to find out, alpha and beta. So when we are talking about some input in which we are having number of input attributes, so we can in general represent that with capital X. Capital X will contain one instance of all the values of values of all the attributes. So here what is the regression equation? The expected value of y at a given level of x is alpha plus beta xi. That is similar to our line equation. Now we are given different values. Now we are not having always the values which are lying on the line. If we are given 2 points, easily we can find out a line equation. But here what we are given a set of data points. On those data points we are trying to set the linear equation which is best fitting. So what we mean by best fitting? We mean by best fitting is we are trying to minimize the sum squared error. So what is our alpha and beta here? How we will calculate it? We will calculate it with few assumptions. What are those? The relationship between x and y is linear. Y is distributed normally at each value of x. It means these are centric about mean of the values. The variance of y at every level of x is same, that is homogeneous. Variance is homogeneous. The observations are independent. This we are assuming. And how do we calculate now alpha and beta? Our beta coefficient is actually a slope. So what is our beta coefficient? That is covariance of x and y divided by variance of x. And how intercept we will calculate? We will calculate intercept from the given calculated slope, that is beta coefficient, using the regression equation. So we will simply take the beta coefficient and we are taking the normal distribution. It is going through the mean. The regression line always goes through the mean. So when we are saying that the regression line is going through the mean, it means that will satisfy the point, that is the average, that is mean of x and mean of y, that will satisfy the regression equation. So that we will put here and we will get the second value, that is the intercept coefficient. So these are the coefficients, and how these are calculated, that is using covariance and variance, and from there using mean value we can calculate the intercept. So this is our regression equation and how alpha and beta are calculated. Now multiple linear regression. When we are having more than one predictor, on the last slide what we had one predictor, that is xi. For yi we are having xi as our line equation. When what is our line equation? Y is equal to mx plus b. So what is y is equal to mx plus b? Y is getting predicted based on the value of x. So here we are having multiple predictor. So if we are having this type of case, that I am having multiple predictor x, w, z. So accordingly my linear regression formula will be multiple linear regression formula. Expected value of y will be alpha plus beta 1 x plus beta 2 w plus beta 3 z, and so on. So what we will have now different regression coefficient. This is for this particular variable. Each regression coefficient is the amount of change in the outcome variable that would be expected per unit change of the predictor. If I make 1 unit change in x, then what will be amount of change in the output? That is defined with its regression coefficient. This is regression coefficient of x. That would be expected per 1 unit change of the predictor if all other variables in the model were held constant. So what will be the amount? It will based on 1 unit change in x when w and z and all other variables are fixed. There is no change in that those are held constant. So this is our multiple linear regression. So in general we can represent the regression method in this mathematical form. Regression methods are used to predict the value of response variable from attribute variables. These are independent and that is dependent, where the variables have continuous numeric values. Now linear regression model fits a linear function that actually defines the relationship between dependent, that is output variable, and independent variables, which is input variable. It expresses the output y hat as a linear combination of the attributes x1, x2, xn given the n data points. This is our given data set xji, yi, where I is 1 to n. So we are given n example, and in each example we are having small n attributes. The linear regression model has the following form. Y hat I is w0 plus w1 x1i plus w2 x2i up to wn xni, where I is 1 to n, where w0, w1 up to wn are the parameters of the model. These are the parameters in general machine learning. These parameters are called weights, and this particular parameter is called bias. So this is our mathematical formula for our linear regression when we are having now n number of independent variable. From those n independent variables, we are calculating here one dependent variable I. Now what we want to do, we want to minimize the error, as we have already discussed. The error is discussed in form of is taken as sum of squared. The squares are taken so that if one residual is negative and one is positive, that should not cancel each other. It should be added properly to get the exact error. So, what is the residual? Residual is EI, means error in ith when actual yi is different from predicted yi. So, this is predicted, this is actual. The difference between actual and predicted is error. Actually, what it is the difference of the data point or distance of the data point from the given line. If I consider this as the line and this is the data point, so this is the difference. This is E. This we will calculate for each one. And yi predicted is what? That we have discussed on the last slide, that it is W0 plus W1x1 plus W2x2 up to Wn(xn). So, in short, we can write it in summation form, that is yi minus summation j is equal to 0 to n wj xj I. This is our residual. We sum up, if we will simply sum it up, it may get a few terms may get cancelled by some of the values. So, to get that proper effect, the proper distance, what we take sum squared error. The total error is residual sum of square error. What is the total error? It is sum of squares, that is actual value minus predicted value whole square and then summation. So, what is our aim when we are learning this linear regression? We want to minimize this sum squared error. So, this is all about our linear regression. Now, if we go through these type of response variable, see, a person smokes or not. When I talk about a person is smoker or not, so either non-smoker or the person is smoker. It could not be 2.2, 2.5, 2.7 or 3.5 or 4.8. So, it cannot be continuous. It will have only two options. Either it will be smoker or it will not be smoker, means it will be non-smoker. So, we are having some type of categorical response variable. This is the second option. Some treatment is given. Now, after taking the treatment, what is the success of treatment? Either the person survives or dies. Only two options are there. So, what we are having particular on this in these examples, we are having binary responses. So, here linear regression formula, that is the regression equation, cannot be directly applied. So, when we are talking about these type of answer, where answer is not continuous but it is discrete, now we will apply to that regression and will discuss how that is applied, and that is the concept of logistic regression. Using the linear regression model, we predict y. It yields predictions that are not necessarily between 0 and 1. For example, we can take our smoker 1 and non-smoker 0. So, we are having two options. Same way we can take example of digit. What could be digit? 0, 1, 2 up to 9. 10 digit possible. It means we can have 10 in output, either 0 or 1 or 2 or 9. Okay, here linear regression is not appropriate. It is inappropriate for these categorical response. So, what is done? The problem is restated, reformed. Now, what we can find out? We can find out that what is the probability that an instance belong to class Q. So, now when we are talking about probability, now it is not 0 or 1, smoker or not smoker. It will be probability that person is smoker and the probability that person is not smoker. So, it means we are having now some real output. It means continuous output. So, when we are having this concept of continuous output, so can we use linear regression now? Now, another problem comes that linear regression can be applied to find out the values. But when we are applying linear regression, then it is not confined to the values between 0 and 1, but the probability is always between 0 or 1. It cannot be 2, it cannot be 1.5, but the linear regression equation can give you 1.5 in answer. Okay, so now we'll talk about logistic regression. So we'll define few terms. First is probability. So what actually we have done, we have restated our problem. Now we are finding the probability that a particular instance belongs to a class. Now what is the probability? It is a number between 0 and 1 indicating the chance of particular outcome occurring. So here we are talking about the probability that person is smoker, the probability that person is non-smoker. Now another term we are defining here is odds. What is odds? Now probability is between 0 and 1. Okay, when we take odds, what is odds? It is the probability of a particular outcome occurring to the probability of not occurring. It means P upon 1 minus P. If P is the probability of occurring, then 1 minus P is the probability of not occurring. So it is the ratio of occurring and not occurring probability. So the odds is a number between 0 and infinity. Now we have, if come out of the range of 0 and 1, probability was between 0 and 1, now we are having odds. What odds is giving us? That is values between 0 and 1. Now again we are facing problem. We said that the regression equation can give us 1.5, 2.5, 3.8. Now we are getting that. If we apply odds, we can get from 0 to infinity. Now another point is the negative results may also come. So we'll take log. So another definition is log of odds. It yields a function that goes from minus infinity to plus infinity. So what we will take? Log of odds. What it is called? Logit function. The log of odds. So we'll apply this to do the classification. Now we can use the linear regression equation. So what will be? It will be equal to log of odds, because log of odds can be any value from minus infinity to plus infinity. That can be calculated from the linear regression formula of W0 plus W1 x1 plus W2 x2 up to Wn xn. And what is log of odds? Log of odds is log of odds. And what is odds? Odds is probability divided by not occurring probability. So probability that x, it belongs to class 1. So belonging to class 1 probability is probability of class 1 when x is there, and not belonging is 1 minus probability of class 1 when x is there. So these are our parameters W0, W1 up to Wn, n plus 1 parameter. These are called weights. This is called bias. So these are parameters of our linear logit function. So we can manipulate it using maths. We can find out from here that from this equation, log of this is equal to this. So we can take P upon log 1 when x is given divided by 1 minus probability is equal to e to the power W0 plus W1 x1 plus up to Wn x1. And then solving for P class 1 when x is there, we will get this equation, that is 1 upon 1 plus e to the power minus 1 W0 plus W1 x1 Wn xn. This is our probability. So what is probability of class 2? So if we are having two classes, class 1 and class 2, what is the probability that x will given, and we will have class 2 as the class? That is 1 minus probability of its belonging to class 1. So this is logistic regression. This way we can do, we can apply linear regression for classification purpose. So this is our logistic regression. We have derived from that log of odds that the equation is 1 upon 1 plus e to the power minus W0 plus W1 x1 plus W2 x2, that is our sigmoid function. In direct values, we have written here what is sigmoid function, what is sig t, that is 1 upon 1 plus e to the power minus t. This is sigmoid function in t indeterminate. This is the graph of sigmoid function. This is a very widely used activation function. So what is the graph of sigmoid function? This is the graph. It can take the values, x can take -2, -4, -6, -8, and what sigmoid will give us, on these values it will approximately reach to 0, and on these values it will approximately reach to value 1. So from here, this graph, we can see that it is lying between 0 and 1. It is lying between 0 and 1. So from 0, from here we can find out, we can get the idea that it belongs to which class. The probability is decreasing to 0 when we are talking about belonging to X. In that case, we will say that it does not belong to class 1, and if it approaches to 1, it means we can say it belongs to class 1. So this is our problem. We can apply maximum likelihood estimation for logistic regression. So we are given a set of observed data. This is our data D. X are the attributes and classes are 0 or 1. Either it is 0 or 1. So what is the proposed model? Probability of y is equal to 1 when x is given is 1 upon 1 plus e to the power minus W0 plus W1 x1 up to Wn xn, which can be written in short 1 plus e to the power, this is vector, weight vector, Wtx plus W0. And what will be the probability that it belongs to 0 class? That is 1 minus probability of y is equal to 1 when x is given. That is the 1 minus probability that the x belongs to other class, that is 1 class. The maximum likelihood approach answers the question that for all possible values of the parameters W, W0, which are most likely? Which are most likely? So what we will do? We will write for each of our observed data point, will compute a likelihood as a function of the parameters we seek to estimate. So we will find out the likelihood, and then after calculating the likelihood function, which is the combination of likelihood for all the data points we observed. Then we estimate the set of parameters which will maximize the likelihood function. We will make the likelihood function, and then we will try to estimate that set of parameter which will maximize the likelihood function. Given the input sample xi, the probability that it belongs to yi, where y is 0 or 1 is probability of yi when it belongs to x. So what we want to maximize? We want to maximize the likelihood. So firstly we will write the likelihood. What will be likelihood? Likelihood will be the product of all the probabilities. What is the probability? Probability that it belongs to, x1 belongs to yi. It is the product of probability yi belongs, probability of yi when xi is observed. And then what we try to find out? We try to find out the maximum likelihood. So what is our goal? Our goal is to find that set of parameters that maximizes L. So what we wish to find out, what we try to find out, that is W bar star. So what it is? It is that argument, that set of parameter which maximizes this likelihood. This is our use of maximum likelihood in our logistic regression. Now, as the log is monotonically increasing, okay, so what we can have? We can have log maximization of log likelihood, because when log likelihood is maximizes, it automatically maximizes the likelihood. W naught that maximizes log likelihood also maximize the likelihood. And what is benefit of taking log? It will become analytically easier. Why? Because the product will be converted to summation, and summation is comparatively easier to calculate. The calculation complexity decreases when we when we convert multiplication problem to addition problem. So that's why we go for log likelihood. By taking the log of this, will convert the multiplication problem to the summation problem. So this is our logistic regression. So in this particular video, we talked about regression, the regression formula. Then we talked about linear regression when the output is real and continuous. And then we talked about the application of regression to classification type of problem. It means when the output is discrete, it is not continuous. So that is our logistic regression. Thank you. Jai Hind.